had y equals 2x plus 4, and we built the table of values 0, 1, 2, and we got 4, 6, 8, and we put it on a graph, yes? Oops. That was backwards. Right? We've done that already. That's not news to anyone, yeah? Okay. Now, if I write another function in math, y equals this, how can y also equal that? Do you understand? Right now in blue, I am saying y is 2x plus 4. But then right here, I'm saying y is 3x plus 2. How can y be both of those things? Does everybody understand what I'm saying? I haven't told you where I'm going with it, but everybody understands that y can't equal two different things. Everyone cool? Now, that's Brody. That's Maggie, right? What differentiates between the two? Don't say one's a boy, one's a girl. Don't say any of that. How do you know I'm speaking of two different people? I could... Damn it, you stopped me early. Their names are what differentiates them, right? Kid, kid. Do you know who I'm speaking of? No. Student, student. Do you know who I'm speaking of? Brody and Maggie. Do you know who I'm speaking of? Yes. So what we do is instead of writing y, we name the function. And we name the function thusly. Thusly. No, that's not its name. The word thus. We name it this way. That's what thus means. We name it this way. We read it as f of x. F is the function's name. That does not mean this guy is named thusly. You know that, right? It's just a word. Okay. So this is the very first function. So, Gershil, if I were to say, we name the function loudly, you would write... It's an adverb, just like thusly is an adverb. English credit. Okay, so this, we can't name him y anymore, can we? Because then we'd have to name this guy y, and all the function would be y. So we can't do that. So we give this guy a name. This guy is f, I'm going to change color, sorry. This guy, but I'm going to keep it blue, is f of x equals 2x plus 4. That means when I'm dealing with this guy, I use this table of values because that is function f. This guy would be named function, for example, g of x equals 3x plus 2. Now you know which function I am speaking of and which function we are going to put on the graph. Is everybody cool? Now you're smart kids. What did I write instead of y? I wrote g of x or f of x, yes? Which must mean that y, which is the output, must also equal f of x. So conceptually, y is this. So when I do my table of values, I don't need to write y there. What would I write instead? F of x, the output. F of x. And what would I write for this guy if I was doing his table of values? Not f of x. G of x. Is everybody cool? Now, if I was going to graph this, the x's are still the same, but the f of x's are the output, which means they're the range, which means where do we put them? On the y-axis. I should change colors. On the y-axis. Is everybody cool? Essentially, if you don't understand the concept, all that is happening is all the y's are now written as f of x.
So we're just changing the name, so we're not saying y equals x, we're saying function of x equals x.
Yes. Now we're going to talk about what that means in a minute, but I want to get you used to speaking of it that way. All right? So last few classes, we've done this way, yes? And what would we do with all these numbers? We'd put them in here, right? So what is negative 2 times 1/2? What's half of negative 2? Negative 1. What is... What is negative 1 minus 2?
Negative 3.
Woo! All right. Now, what is 1/2 of 0? 0. What is 0 minus 2? Yeah. What is half of 1? Decimals? 1/2. What is 1/2 minus 2? No. Negative 1.5. And what is half of 4? Minus 2?
0.
Yes. All right. All of you can do this, yes?
Yes.
How did we get these answers? What did we do to get those outputs? We followed the equation and we did what?
We plugged the x into we plugged the variable.
We took the x values and put them in for x, yes? Easy peasy lemon squeezy, yeah?
Yes.
What is the new way that we are going to write this? Addison?
Function of x equals 1/2 x minus 2.
Agreed?
Yeah.
Okay. What letter does that negative 2 represent? X. Because we put it right there, yes? 1/2. And I'm going to change color. Negative 2. Minus 2, right? The f of x is this, right? But the f of 2, sorry, not 2, the f of negative 2 is this. Does everybody see? I'm about to. What letter does that negative 2 represent? What letter do you see there? So what do we put there? What letter do you see there? So what do we put there? Negative 2. Our input, our function of negative 2, because negative 2 is what we input, will result in what output? Negative 3, right? So the f of negative 2 is negative 3, right? Negative 2 was an x. Negative 3 is the result of f of x. So that must be an output, which means it must be a range, which means it must be on the y-axis, which means it must be a y value. If you don't totally get it right now, you know we're going to do 27 examples. But if you're starting to scratch the surface, everyone should be good because it's exactly the same thing we've already done. When we had just a y here, we replaced the x with this number, yes? But now we've written another x, so we just replaced that x with the number 2. Oh, I shouldn't have said the number 2. The number also. Everybody okay? Because I know there'd be some kid that would always write f of 2 because I said we replaced that x with the number 2. Thusly. You would write it thusly. All right. Is everybody cool? All right, so let's drop down and let's try one of these. And this is where we're going to stop today. Okay? This is written as the f of x is 2 minus 7, yeah? Don't write down what we're about to write down. We're used to seeing this as this, yes? Right? Okay. This is what we have now. F of x equals 2x minus 7. I need the f of 2 and the f of negative 3. What has that x become? So what does this x become? 2 equals 2. What does this x become? 2 minus 7. What is 2 times 2? 4. What is 4 minus 7? So the f of 2 is negative 3, yes? So what is the ordered pair that would go on a graph? What is the xy value? 2, negative 3. Is everybody cool? Okay. What's going to happen with the f of, what's the x become now? Negative 3 equals 2 times what? Negative 3 minus 7. What's 2 times negative 3? What's negative 6 minus 7? Negative 13. So the f of negative 3 is negative 13, yes? So what is the xy value that would go on the graph? Negative 13. And we're going to stop.
What's that supposed to be on the right side, the minus? Like
7.
That's a 7?
Of course it's a 7. Looks like all my other 7s. What? There's not. It's 220. I got to go in to check my progress. I got to make a task. 12. 9 plus 3. Huh? Well, no. All right. Now, does everybody under DC, under DC, under DC, under DC, things are better down where it's wetter, under DC. No, take it from me. That's how it goes. Anyways, does everybody see that the only thing that has changed is just, instead of writing y, we write f of x. Thusly, yes. Use it 3 times today and it's yours forever, Gersa Hill. This is how you use it. If you ever are going to show somebody something, you say, we do this thusly. So for example, you're teaching somebody how to fry an egg. Person says, I don't know how to fry an egg. You say, we fry an egg thusly. We take out a pan, we put it on the stove, we crack an egg. But you never crack egg to pan. No. Egg to bowl, bowl to pan. Or you'll break your yolk. That's no yolk. Oh, that recorded. Now everybody knows how to fry an egg.